All right, let's start. Before we talk about inheritance, I would like to talk about some exercises for you, okay? That could be useful for just strengthening the concept, okay? Inheritance, we'll definitely get to it for sure today. But I'd like to start with some exercise. Sorry, just, okay, take some time. Okay, let me launch my iPad. Okay, remember what we said last time, the single pattern. Let me review very quickly the essence of that. Basically, we say for separation of concern, for cohesion, we basically got two classes over here. So one is called data access. Let's say data to start with. And then we also got data access. Let me put data on the right-hand side over here, so easier for me to draw. Okay, that's how you review the whole pattern. And then we got another class called data access. Okay, data access. And data access basically has nothing but just one single feature, data. Okay, of type data. Over here. Of course, correspondingly, you should really draw client-supplier relations over here, right? And the label should be data. Okay, plus is effective. And now there are two concerns over here, okay? And let me just say one more thing. And then in the data class, of course, you may have some exchange rate, also interest rate, etc., right? And also you have a constructor called make. So this is a constructor, okay? So now we have two requirements to satisfy. Number one, we want to make sure sharing is really achieved, which means there's only a single copy in the universe, okay, in our system. And number two, it's about cohesion. Okay, so these are the two requirements we want to satisfy. Okay, so now for sharing, remember we have in the data access, we have an invariance over here. And for invariant, we simply say data and data, right? And now, should we put equals or tilde, or doesn't matter? Equals, right? It's about references, okay? Keep that in mind. Data equals data. And how do we achieve that? The way to achieve that is by saying the data over here should be ones, right? Something here. That means as soon as after the first call to the data, the reference will be cached. So every time, for all the subsequent call, you will just return the cache reference, right? That's how we achieve sharing. All right, so number two, cohesion, by the way, is already achieved by separating into two classes. This part has no problem. However, let's say according to the current setup, do you think the design is correct in order to make sure 100% sharing, i.e. there should be no more than one instances of the data according to the current setup? Am I missing anything here? Yeah, let's say, according to the current design, is it possible for me as a client to create multiple instances of data? Is it possible, according to the current design? Give you a little bit hints. If you can pay attention to the data class. Export status, right? Because according to the current design over here, pay attention to this guy over here. Make is just a feature, right? I didn't say it should be restricted to any potential clients. So at the moment, it's simply just public, which means any other client can simply say creates data dot make. Another client can also say the same line again by calling creates data dot make in different classes, basically. That's a problem. That's how you can create multiple instances. And how do we fix it, right? Last time, you actually saw the following. I'm going to review that part. That's something I want to explore a little bit further because many of you got some concern. Okay, I want you to just look at the diagram from last time very quickly. Okay, I'm just temporarily going to. So this is the correct version, which means you have to restrict the status in two places. Number one, after the creates, we're going to say data access. And after the feature, we're going to say data access, right? That's how you achieve that. You got to get both, okay? But now, let me just explore a little bit further to tell you what they really mean. Okay, let me undo. Okay, apart from that, that's about the review of the singleton pattern. Not too difficult. You just got to remember which are the two requirements you want to satisfy and go from there. Okay. Any question about singleton pattern specifically? Anyway, anyone? Go ahead.
What is
No, good question. The question was, what if we have multiple instances of data access? Would that actually give us multiple data instances? The answer is no, right? But why, right? Let me say this. Let me say if I got, let's say just in the same test feature, okay? If I say under local, I simply say data access, I'll say DA, okay? Data access 1 and also data access 2. And then declare them to be data access, okay? And now I have do embody over here. So now, let's say data access is not expanded, let's say. It can be, but it doesn't have to be, okay? If it is not expanded, what we would say creates, first of all, da1 dot make. And also we can say creates da2 dot make. So far we got 2 data access objects, right? Not data, not yet. Let's try the following. Let me just continue into here, okay? Continue here. Now if I have, let's say, data 1 and also data 2. And then we simply got data over here. And then we say data 1 is assigned to da1 data access dot data. So I'm basically calling this once routine, okay? And then I say data 2 is assigned to da2, right? That's the, basically I'm trying to get a data from 2 different data access objects. Your question was, after these 2, if I try result is assigned to, let's say data 1 equals data 2. You would say false, okay? Anybody else? Either true or false, right? Anyone who would think that should be false, intuitively. You think that should be false? True? False? First of all, let's agree. If this evaluate to be false, that means a singleton pattern is not working. You can never stop any other client to create another data access object, right? However, this is going to be true for the following reason. When you try to call, think about the once routine over here. It's more like a construct that's going to be managed globally. So alpha runtime is going to take care of that. So let me highlight it. So if you look at that over here, once over here, so this guy here is going to make sure just the first call is going to be recorded for the reference. Any subsequent call, doesn't matter from which object. It can be data access 1 objects, data access 2 objects. There will be just subsequent call, right? So that is why over here, if you look at the call over here, da1.data. So this is the very first time you call this particular once routine, right? So now this is the point where you create instance of the data. And the second one over here is going to be the orange one. Even though the context object is different, being da2, however, it's still a second call to the same once routine. So this will just give you the cache reference, right? Okay, it's a very good question. I'm glad you asked. Okay, so this, oh, one moment. So this is just a subsequent call after the first one. So that means it's going to be cache reference. Questions? So there are 2 aspects for the singleton pattern. R1 is about sharing. In order to do sharing, you must make sure you have only a single instance in your system. So for that aspect, use once. The second aspect is really about cohesion. You want to separate the 2 concepts about sharing and the data, 2 different concepts. For that one, you have to use some export status to enforce. Right?
So what happens if we only had one export status instead of the 2?
Oh, that's exactly what I'm going to explore. Yeah. So the question was exactly what I'm going to address now. Let's play with a slightly simpler class with all kinds of combinations of the export status, and let's see what happened. Okay, that's what I want to go through. Okay, let's try a very simple class over here. Let's talk about this. Let's say we got supplier, and then we have create and make, and then we got make over here. Initial value, assign the attribute to initial value, only a single attribute, right? Very simple supplier. And then let's, I'll explain the essence in just a moment. Let's go over the code, very easy code. Client 1 and client 2 are simply two different client classes. Both of them declare S and old S. I'll talk about what OS really means. It's for a reason. Both of them have the type supplier and also SOS supplier. Okay? And the code is exactly the same. We're simply trying to create some new objects of type supplier and then try to call also make on that. Okay? That's kind of the code structure. I'll go over line by line for the first case. So now, this is the simplest case. The simpler case, let me clarify one thing first. Let's say this. If you only look at the feature of make alone, okay, it is a command. It's not query. First of all, it doesn't return anything, right? So this is a command. When you declare the create clause over here under the class, that simply means out of so many commands in the class, I'm going to select the following list to be constructors. So any commands or any mutators can become a constructor. Unlike in Java. In Java, you have constructor must have the same name as a class. In iPhone, no. You can choose any commands to be a constructor. Okay? In the extreme case, let's say this. I might simply say, I say creates, but I don't have any command over here. So what would that mean? That simply means there's no way to create instances for this particular class. Just no way. Okay? Not very useful, but it's possible. Syntactically allowed. Okay, let's go back here. Okay, so here, in the first case, we simply say make being a command. We simply choose that as a constructor. Okay? So now I want you to look at just client number 1. Okay, having that in mind. Let's have a look at client number 1. Client number 2, just the same. Okay? Let's try to trace the code very quickly and then ask you about it. Let's say I want to say create s.make. In this case, create is just like a new keyword in Java. So we are creating a new object. Okay? And now let's say we simply assign the reference of s, the object we just created, to OS, old version, before we make any changes. And now, if I say create again, create s.make, you can notice that these two lines are just identical. Okay? And then I try to print over here, saying OS and S should have the same reference. Before I draw a diagram to help you, do you think this should print false or true? Okay? Why would that be false? Yeah, you're basically using the like a create twice. That means you're creating two objects, right? That one should be easy. Basically, think about after this line over here, S is simply pointing to the supplier object with initial value 5. Okay? And then we say that OS is going to assign to it, like that, OS. And then after the second creates, it's a separate creation. We're going to create another object of supplier over here and let S pointing to it. So that is why OS is pointing to the original objects, and S is now pointing to a new object, also of 5. Different objects, right? Basically, the principle is every time you're trying to use the create, you're creating a new object. Okay? Let's go a little bit further. Let's keep the way it is now, and then we're going to say, let's do the next line. We're going to say OS is assigned to S again. So that means OS is now pointing to this light green object here, right? That's what we're currently dealing with. And then notice the next line. I say s.make rather than create s.make. Okay? So now, what should be the value of print? True, right? Okay, what's going to happen is, this is a call to the command. And these two are calls to constructor. Even though you're both calling make, but since the create keyword tells you, it's creating a new object, that's the difference. Okay? So after this, you are not creating any object, so you're still referring to this one here, and you're making sure its value has been assigned to 7. Okay? It's a very quick clarification if you're wondering about what's the difference between creates s.make versus s.make. They're different. Okay? Any question about this? Okay. We haven't talked about export status just yet. Okay. So now let me say one more thing, and then we move on to case number 2. And the client code looks just the same for all the other 3 cases, just the same. What I want to do now, let me clean this a little bit over here. Okay, just over here. Implicitly, it is having no export status over here is as if we said it's going to be exported to any. Any is like the object class in Java. That means the top class in the hierarchy. Okay, any is just like objects. So that means any client class, any descendant classes of any can try to use make as a constructor. And then implicitly, it's also like we put any over here as if. So that means any class can actually use make as a command. So the purpose is important. Either you want to use make as a constructor by using the create, or you simply just want to use make as a command. Okay? Is it clear to you? Okay. Let's try. Let's modify things a little bit. Okay? Let's go to case number 2. Okay? The same setup to begin with. Let me say, I'm going to say over here, creates client 1. That's the only change I made. Are all the 3 classes going to compile right now? Okay, that's a good sign. Which class wouldn't compile? Client 2, you guys are smart, that's very good. Can you tell me which line? The 2 create, right? Because this guy here simply tells us, okay, let me write it down. Simply tells me only client 1 can call make as a constructor. Okay. However, any because there's no export status over here, any class can call make as a command. All right. Okay. So that means this wouldn't compile. This wouldn't compile. Okay. Hopefully, you got a feeling about this, right? Better. Case number 3. What if I change this guy over here to be none? And this somehow corresponds to your lab test yesterday, if you remember. Because some of you asked me, oh, I actually got the make exported to none. Can I call that as a constructor? Some of you actually asked me. So I simply said, oh, yes, you can. Actually, I said, no, I didn't say you can. I just say try. Right? Of course, when you try, you'll realize you can. Positive. Question. Yeah. So now, let me, don't worry about what I just asked. Let's say this. I changed this to be exported to none just for using make as a command. So now, are all the 3 classes together will compile? Which clients? Both of them, because it's none, right? Very good. That's one possibility, right? So none of the classes can actually call make as a command. Let me relax this constraint a little bit. Let's say, what about I only put client 1? In that case, which class will have a compilation error? Client 2. Can you tell me which line? Yeah. First of all, would this line compile? It would, right? Because you can still use it as constructor, not a problem. There's no export status. On the other hand, when you try to call that over here, this will not be good, right? You cannot call that as a command. Make sense, guys? Okay. Yes. Can I? Yeah. Yeah, absolutely. That's exactly case number 1. Yes, you can definitely do that. That's if you forgot about it, let me show you. If you see that, right, you can restrict the create over here, right? After the create, you simply say only this class or its descendants can call this as a constructor. Okay.
So for case number 3,
yeah.
If we have it set up this way, basically what we're saying is we want the client to be able to create objects but not modify them after they're created.
Okay, more precisely. Case number 3 has the following implication. You allow any clients to use make as a constructor to create the objects of type supplier. However, you don't allow any clients other than client 1 to call make as a command. However, you may have other commands in your class that have no restricted access, in which case they can call. So that's why you got different feature sections in iPhone. So you can, for each section, you can have different status for export. Right? Yeah. Questions? Yes, client 2 apparently is not client 1. So when you actually have this particular feature here saying make can only be called as a command by client 1, anybody who's not client 1 cannot call that. That is why it's a compilation error. Correct. That's correct. Yes, that's correct. All right, final case. You can imagine what I'm going to do, right? Basically, I try 0, 0, 0, 1, 1, 0, and 1, 1. What's 1, 1? Do you see what I mean? Okay, okay, yeah. If you don't see what I mean, that's not important. Okay. So now here, what if I put none over, maybe let's say none. Let's say client 1 over here, and also I put client 1. Okay, we should agree there should be errors in client 2, right? How many lines do we have errors? 3, good. 1 here, 2 here, and 3 here. Only client 1 can use make as both constructor and command, nobody else. That's exactly what you saw in the singleton pattern. We want to restrict the access to make such that only data access can call the make in the data. Okay. However, if you do want to allow some other commands in this particular class to be modified by other client, you can create it. For example, that's the final point I want to make. You may just put another feature over here, which is exported to any, in which case maybe after this you can say set I, and then you can make that command available. You just don't want to make the make specifically. Okay? Okay, any questions about this? Okay, yes?
If we do a case where we have like create client 1 and then feature client 2, would it be the case that one client would be creating it and the other one would be like modifying it?
Yeah, you can definitely play with it. So the question was, what if I try to say temporarily, okay? Let's say this is client 1, this is client 2. Well, again, it's very obvious to see what's the rule. You're saying that only client 1 can create objects of supplier. However, client 1 cannot call the command, and vice versa for client 2. That's fine. However, you've got to ask yourself, would this kind of setup be consistent with my design decision? If it is, go ahead, no problem. Okay. You know, I'm not too sure. Maybe you just want to have some access control to say for this particular client, they can only initialize the objects, but nothing else. But for another client, they will take over from client 1, right? I don't know. Yeah. So it completely depends on what you want to do. Right? Okay, so I have 2 exercises about postcondition for you, right? Inspired by your questions offline. Okay. First one. Let's say we have an input array of integer, want to decide whether all the numbers are positive, and then Boolean. Okay, that's the postcondition I have. Is it okay? I heard no. Okay, hold your thoughts. Okay, I'll let everybody have a look. I'll give you a few seconds. By the way, this compiles. This compiles. However, it has a very terrible logical mistake. For those of you who already see the problem, I would like you to, the way to explain is by using an example, right? Okay, one moment. Okay, I'll just give 10 more seconds for everybody, right? All right, anybody want to give me an example where it will lead to something that fell? Give me an example. Yes. Okay, I can see you're getting in the right direction. Okay, anybody else want to try? Jordan.
It's like a for each, so you're just grabbing the elements inside and nothing indices.
Aha, very good. That's the essence for the example. Okay, let me first of all understand abstractly what the problem is. When you say across A is I, what's I? Is I an integer index or integer elements? However, you're using the element as an index. You have contradicting purposes. Right? That's a problem. Okay? And Jordan, you want to give us one example?
Okay, let's say the array only has the number 5 in it.
Okay, sure.
Then you would grab 5 and put it as an index and you get everything else.
Exactly. Yep. Because 5 over here has index 1, right? And now when you say I over here, it would just to be one member of A, in which case I would be 5. And then A5, nope, you got index too large violation. Okay, that's kind of interesting. Okay, I wouldn't put this on the exam. That's a bit too tricky, but it's for your information. Okay? Okay, this one is good. Okay, if no questions, I'll go for another one. Okay. Let's say we have this. We have names array of string. And then we simply want to have very simple, just a name at this particular position. We require that the index I should be valid for the array. Okay, that one is no problem. Now I want you to look at basically these two post conditions. Okay, these two. Question number 1. Is this fragment going to compile? Number 1. Okay, I heard that. Okay, can you tell me which line wouldn't compile? Actually, nothing to do with the numbers, I can tell you. Oh, you know what? That's a good point. That's not what I intended. That's definitely not what I intended. If you don't mind, I'm actually going to say that's definitely what I intended. Can I actually change this? Okay, if you don't mind, I'm going to just temporarily change this to J. Okay. But you're right, you definitely cannot use the same variable. I agree. However, that's something else I want you to catch. Okay, now we are okay. How about this? So now that is not an issue anymore. Yes.
Would you have to do like a twin or a deep twin?
A deep twin. Okay, let's talk about compilation first. First question: is this code going to compile?
Well,
I heard no. Okay.
is that you have like 2 checks and you're not connecting them.
Oh, it's okay. Remember we said each new line is like a conjunction, right? Yeah. So that's not an issue. Oh, did you raise your hand? Yes, go ahead.
The brackets around only.
Ah, that's good. But what's wrong right now? You're talking about the second occasion of old, right? Why would that be a problem?
So you're talking about the second. Yeah.
The second one, right? You're basically talking about this guy over here. You're basically talking about this. What's wrong?
Because it's going to the input J at index J. It's not saying
Yes. Yeah, let me help you a bit. You definitely need brackets. So the problem is you're going to cache this expression in the pre-states, but J doesn't really exist. Right? Exactly right. Okay? So now the question is, how should we should bracket them? Let's fix this first. As soon as you put the brackets over here, you will be okay. As soon as you do that. Okay? That's something we talked about before, but some of you still got the issues over here. Now, let's talk about the green one over here. The second part I want to talk about, so now everything compiles, but there's a logical error. Okay? I want you to tell me over here, you can see this guy over here and this guy over here. Are they appropriates? Okay, how about this? Let's go by one. 1 here and 2 here. Is 1 appropriate? I heard yes. Most of you will say yes. Anybody will say no? You will say no. Explain, please.
Because they can still add something.
Yeah, you definitely, your implementation can maliciously add something to it which is not intended. But why would the post condition not catch that? It's the same reference. Okay, so 1 is actually not right. Think about what 1 is going to do. 1 is going to say, if I have my names array over here, okay, in the pre-states, this old is going to apply to just names, right? So that means the old expression is going to point to the same array, meaning that if your malicious implementation simply try to change something over here, or even grow the size of the array, they are still pointing to the same array. So you cannot tell. Okay, very brief description. So for this guy here, how can we fix it? Okay, one way to fix it, that's the main point I want to illustrate. Either you can say old names dot, should we say deep twin or twin? Okay, question here. Twin, deep twin, or doesn't matter? Oh, you know what? In this case, it doesn't matter. Why it doesn't matter?
Because a shallow copy is going to be the object or have old references, which is specific to the object overall. Don't care about the references. Don't care about the content.
Why would you not care about the content in the first post condition?
It's not necessarily the activity against
Yeah, you only worry about the count over here. Okay? So let me say this, okay? Over here, let's try to write both versions. Over here, you can actually write either old names.twin.count. Or you can say old names.deeptwin.count. Both actually work. Because as far as this condition is concerned, all you want to do is call the count. The shallow copy is going to create the array brand new anyway. So even if you modify the contents of the array, that has nothing to do with the size. So size remain to be the same. Okay? This requires a little bit more thinking. Okay? Think about it. Having said this, is it possible to use it without any copy? Put a count in the brackets too, or simply remove. Actually, you cannot remove the brackets. Sorry. Yeah. So what about this? Oh, actually, you know what? What if I just remove the brackets? Yeah. So now this is the third version that will work, which is even more efficient. What if I say old names.count? Would that work? Yeah. Because think about what this one's doing. It's simply just going to record what's the size of the array in the pre-states. Let's say it's 5. If the malicious implementation grow the size into 6 versus 5, you can tell. Okay, so this is also fine. Okay, guys, I think this exercise is more worth your attention. Okay. Yeah, this one also work. Yeah, this one also work. Yeah, but the more important stuff is about understanding why all of them work, all 3 of them. Okay. All right, good. So let me reveal. I believe that's kind of the solution I put over there. Okay, so basically, okay, you can have twin or just old names that or deep twin, but deep twin is not necessary. Okay, finally, what should we do with this guy over here? Now, can we use reference copy in this case? Can we use shallow copy? Simply because we are talking about a particular element in the array. So we want to make sure any change beyond the first level can be seen. Okay, so the only way around is to say old names.deeptwin, and then I. That's the only way. Okay, think about the issues over here, right? Hopefully I'll re-emphasize. Okay, that's the only way you can do it. Okay. Any question about this example here?
Can you spend one more time on why the original condition of the first one doesn't work? Like all things bracket dot count?
You mean this guy here? Oh, you mean the first one, right? Sure. Let me have a new page. If the post condition looks like this, count equals old names dot count, right? Think about what happened beforehand. Let's say before the body of the implementation is executed, you have the names pointing to an array, like that, okay? And now when you see over here old names, that means I'm going to make a reference copy of the names, right, in the pre-states, right? So that means there's some old expression over here is assigned to, oh, let me put it in the right place. So that means in the pre-state, I'm going to say old expression is assigned to just this verbatim, right? It's as if making a reference copy. So that means old expression is pointing to this particular one, okay? Let's say we try to execute an implementation over here. Somehow, part of it is going to grow the size of the array, right? So now, when we try to evaluate this guy over here, would it give us true or false? True, because names.count, oh, sorry, names.count, I forgot. Names.count would just be 1, 2, 3, 4, 5, 6. All expression.count will be the same, because they point to the same objects. But it shouldn't give you true in this case. It should give you false to signal the error. Yeah. All right. Any other questions about this? Okay, hopefully everybody is comfortable. All right. The next one will be about inheritance, okay? So the idea is for today, I'll do something very quickly just about the code reuse part, how you can use certain keywords for inheritance in IFO. You will need that for later labs and also projects. That part is very easy. I won't bother you too much. I do want to emphasize single choice principle again and give you a little bit motivation about what if you have no inheritance, more about typing aspects. And then we'll give you a very interesting case study. How can you test your post condition using inheritance? That's a little bit more advanced, okay? That's kind of the agenda for today. Let me see if I can cover all of them. Okay, inheritance. Okay, so there are two aspects for the inheritance. One is about the code reuse, just about how you can use the inheritance, how you can reuse the code from your parents. That part is very easy. You got the idea from 2030. Number two is about substitutability, okay? Basically, just about if I'm expecting type A objects, can I give you type B objects? Can I or can I not, right? This is some principle behind that. We're going to review it, okay? All of you, more or less, listen to something to some extent of details, but I'm going to assume none of you have heard that. Right? Okay, so for substitutability, two things we're going to cover. One is called polymorphism and dynamic binding. You learned about it in 2030. Okay. The number two is, okay, this is more like compiler time check. Number two over here is something new. We're basically talking about, let's say you have a class called A. A has some precondition and postcondition invariants. And then we have a child class called B, which extends A. Now, what would be the contracts that will be inherited to B from A? That's the question, okay? That's something we'll talk about after the reading week. Basically, we'll talk about what's gonna, how decide by contract can work in the context of inheritance. Okay? That's something we'll talk about. That will involve a little bit of logical reasoning, which we have to spend some time. Okay? But we'll get there. Okay, so now, why do we need inheritance? Let's go very quickly because you already took 2030. So this one shouldn't be too strange to you. I want to highlight some different, some important stuff. For those of you who didn't take 2030 with me, so this will be a new example. Otherwise, it will be the same. But you might forget anyway. Okay? Why don't you spend just 1 minute, please, read over this example. We're going to use it for the review. Okay? I don't think, Michael, you have seen that, right? Have you? I don't think you have seen this one. Example. Yeah, good. Yeah. Well, the guys sitting at the front, I'm pretty sure they have seen that. Yeah. Okay, have a look at the nouns, verbs over here, and think about what should be the clauses and what should be the methods. Okay? Okay, the question I want to ask. I want to design classes that can satisfy the above problem statements. At a runtime, we must be able to register a course and calculate their tuition fee. Now, since you're not taking 2030 anymore, I want to add an extra question to you. Okay? Let's say in the student management system, I want to maintain, let's say either an array or a list, doesn't matter. Let's say a collection of students. How can I achieve that? Just one single collection, rather than different collections. Okay. Okay, I'll give you 30 more seconds to read it, okay? And then we'll talk about it. Okay, everybody comfortable with it? Okay, we're going to use this for the next 2 or 3 lectures. Okay. Huh? Oh yeah, more time? No worries, absolutely, absolutely, please. And what I promised to do this year, I'll update my smartphone example. If you learned that from me from 2030, I'm going to update that. Yeah, the models are pretty old. Yeah, anyway, you'll see what I mean next week. Yeah, not this week. I'm still going to need to update that. Yeah. Oh, which means every course has, for example, 3311 might cost certain money. Maybe 2030 costs maybe less or more, something like that. Yeah, hypothetically. Yeah. Yeah, let us know when you're ready. Waive the fee simply means you don't have to charge them for this kind of fee, right? So basically, okay, you can see, you can think about for non-resident students because they don't live on campus. So that means you don't have to charge them for some fee. So that's why they would be charged less. That's what I mean. They will still be charged, but maybe less. That's what I mean by waive. Yeah, just you can deduct some fee, right? Yeah. Are we good? No problem. Yeah, we're going to review different aspects very often. All right. So now, how many classes? 3. Okay. You all know about inheritance. You may just get a student class, also resident students, non-resident students, right? Good. Let's pretend you didn't know that. Let's pretend. And let's now go over very quickly a design where we don't have inheritance. I just want to point out how single choice principle can be explained over here just one more time, okay? And then we'll go to inheritance. Okay, so we got a course class over here. Okay, so now let's say for the course we got title, we got fee, right? That's basically what you were asking for, right? So we got course, it got create, make, and now question for you. According to what we said, what clients can call the make as a constructor? Everyone, right? There's no restriction here. Good. And then, so we got title, we got fee. Okay, pretty good. And now, let's say no inheritance. We have a class called resident students. Okay, resident students over here. And then we got constructor make. And then we got name, we got courses, let's say linked list. And also we got premium rates. Okay, you can think about premium rate is what distinguishes between a resident students from non-resident students, right? And then we got constructor make, which will initialize the name and also initialize empty collection of courses, right? And also you got set premium rates. And also you got register, you just extend the course list. And then we got tuition. So basically the way we calculate, just say calculate some base and then to see if you should be charged more or less, right? Base will just be go across the courses, simply add up the fee for individual course, right? Oh, this kind of old version, I'm still using across S. You can definitely feel free to say across is. Doesn't matter. Okay. And then we say result is whatever base amount you have, multiply premium rates. Okay. So now my question is, if let's say this is what you define, no inheritance. If you have to define non-resident students, how similar will they be? What will be the differences? The highlighted part, exactly. That's why I highlighted, right? So if you look at the next slides for the next class, non-resident students, name is different, for sure. And also, you still got a constructor here. And notice that we already got duplication. You got name, you got courses, you're declaring them twice already, right? Every time you got duplication, that means your design smells. You want to get rid of that smell if possible, right? So you got discount rate as opposed to premium rates. Also, you got also constructor. You can see also you're also again repeating the same pattern for the constructor, right? Initializing empty set of courses. Also set discount rate as opposed to set premium rates. Register and also tuition. So now the tuition is interesting. It's not entirely duplicating what you did in the resident students class. However, much of it, you can see the way you calculate the base up to here is pretty much the same, repeating. However, it is this part, it has to be different because they're multiplying by discount rate. So now, if you want to look from the code reuse or minimizing code duplicates perspective, what you want to do is identify how similar are the two classes and then factor out the identical parts into a superclass. That's how you can think of it by the reuse perspective. Okay, that's what we'll do today. Okay. Okay, so now what we will do is let's now consider something. Okay, of course you can just test your classes, right? For that one, I wouldn't bother you too much. It's easy. You just create new courses, set the premium rates, and do the register, right? And then just test them. Okay, and they will simply calculate the tuition, etc. That one's very easy. Okay, we don't have to waste time. Okay. Now, let's now talk about the issues over here. Basically, without the inheritance, everything can still work from the external tester's point of view. Everything can work together. But now we want to think about what can be the potential problem for this kind of design, where you got lots of duplicates, right? The idea is, whenever you got lots of duplicates, conceptually, that's how you can think of it. Okay, let me switch the iPad over here. So now, let's say this is your project over here, right? Let's say this is a fragment of your code. It's repeated somewhere here. It's repeated somewhere here. It's also repeated somewhere here. Okay? So now, conceptually, if you have to make a change over here to be consistent, you have to make it in multiple places, right? That's a problem. Okay? Having inheritance is going to eliminate the problem. At least you can make it lighter. Okay? Let's now have a look. Okay, duplicates code, make it hard to maintain your software. Okay, let's give one example. Okay, you have that's basically the single choice principle. Every time you want to really, let's say this, we want to change the policy of, let's say, registering a course. Let's say maybe there's an upper bound. Currently, there's no upper bound. If we want to change it, how many places do we have to change? That's the question, right? Okay, more than one places, and then that's called single choice principle. Okay, that's the that's the principle you want to think always together with information hiding. So these are the two most common ones. Okay, so now here's the definition. Whenever there's a change needed for your software, there should be either a single place or sometimes it may have multiple places, maybe unavoidable in practice, but at least it should be a minimal number of places that you should change. Okay, it shouldn't be too many. Okay, if you can minimize, you should minimize. Okay, that's the definition for single choice principle. Okay, so now let's say just say one change. Okay, let me just go to over here. Let me see the one I have over here. Okay, let's say we want to change away for registration. Okay, I'll just demonstrate this on the iPad very quickly. Okay. Okay, I want you to compare these two classes over here. Okay. Okay, we got non-resident students, and also we got resident student, right? They have nothing to do with each other, just two separate classes, okay? You can see currently, if you look at the register over here, they look identical, okay? And you can see currently we simply, every time you want to add a course to your registration record, you just add it. There's no upper bound. Let's say we want to introduce an upper bound to say you can register for no more than 5 courses, okay? So now, easy question. How many places do you have to modify in your design? 2. It's very easy to see, okay? So basically, I'm going to say over here, I would say if, for example, the courses, the count is, for example, less than 5, let's say, In that case, I can add a course, right? But if you only change this single place, that's not enough because you got duplicates of your code. That will cause inconsistency. So what you should do is you should also do the same change over here, and then you're gonna say courses dot count less than 5. Then you gotta repeat this for many times. So you're violating the single choice principle. So what can this be asked in the exam? So we might simply present to you either bound diagram or some small fraction of alpha code, but different classes. What you have to, we can say, can you identify any design flaw over here? If you see any duplicates between classes, most likely single choice principle. Okay, that's easy. Okay, and imagine that in a slightly more general situation, if this is your student class, okay, and then under which you have so many different, oh, actually I shouldn't say inheritance over here. Let's say this. I think what I meant to write is this. Let's say realistically, let's say we have student, let's say resident students. Let me write properly. So you have resident students, and also you have non-resident students, and also maybe international student, etc. Right? You got many, many student classes. As every time you change a policy, you have to go to every class over there and manually change them. Right? That's the drawback for this design with no inheritance. Okay? Any question about this? Most of you should know this already. The only thing new is single choice principle. I want to highlight. Yes.
Would it be a bad design to just have a boolean that says, like one student class and a boolean that says resident equals
Okay, you're basically asking, you know what? Okay, let me talk about this. That's you're basically saying this. You want to have just a student class where you have a Boolean attribute, maybe is residence, for example. Right? That's what you're suggesting. Before I give my feedback, anybody? Do you think this might be a good design? This is actually a good question. I agree with you. Well, you're in the software design class, right? So now, actually, I'm pretty sure some of you might propose this alternative to me in 2030 when I talk about the same example, right? But now we are in a better ground to judge. What would be, do you think this design might be good or bad?
Clutters design so everything removes classes or separating.
Okay, you're saying, but you know, somehow I'm just saying, I'm including the attributes over here. That one simply says whether this student over here is a resident student or not. So it somehow is relevant. So I would say cohesion is not a problem over here. Chelsea. Okay, that's one drawback. What if you have, let's say, 5 kinds of students? Can you encode 5 possibilities into a Boolean? Boolean can only encode 2 possibilities, right?
So are you asking if it would be like a resident international student?
Yeah, let's say, or just saying in general, let's say we got 5 different kinds of students. Either it can be kind number 1, kind number 2, up to kind number 5. In that case, the Boolean over here may not be enough to encode the 5 possibilities, right? Let me help you with that. Let me help you. What if I simply, I'm just trying to improve your design a little bit, right? Let's say I change this into the kind. Just make it integer. 32-bit integer, you got 2 to the power of 32 possibilities. That should be more than enough. Chelsea, what would you say about that? That solves your problem. So that means every time if I want to have some feature about a student, if I want to determine, I can simply say s1.kind. If it is equal to 1, I do something. If it is equal to 2, I do something. Yeah, I may have a big switch. We have if statements. Maybe nothing wrong with that. Maybe. Or there's something wrong with that.
Are relying on magic numbers and you don't have a way to check to see if all the cases are checked.
Okay, you're saying maybe logic, magic number. I can easily solve that by saying, for example, I'm just trying to improve even further, right? I can say in the student class, I can say, for example, let's say resident students which is of type integer. And that one, conceptually, you can just say is 1, let's say. So every time you want to refer to resident student, just say resident students. You don't have to say 1, right? And then also non-resident students, and then also integer equals 2, right? All the way. I can define constant, okay?
You still don't have a way to check to make sure that you're handling every single case.
I like that. So somehow you want to, well, that's somehow every time you want to check to see exhaustively, that's the issue. Yes, I agree. We'll get there. Mm-hmm. Guys, I can tell this is important, right? I meant to talk about this in the state design pattern, but it's good to talk about it now. Just give you more reinforcement. Yes. Are you trying to contradict your own design, or are you trying to argue for that?
Yeah, I just like maybe if it's, I know like if you have a lot of different estimates.
Let's say we have a lot, let's say. Even 10. Okay. Let's say 10.
But I was just going to say maybe you could have like 3, 4 variables.
Oh, that would be even worse, right? You can say 0, 0, 0, 1, 1, 0. What's that, right? You got to have some encoding there. I tell you what, even that, I wouldn't be so much against, okay? You just got a way to encode the kind of students, right?
So like if you have a constructor, and then in the constructor, like you pass it.
Yeah, I tell you what, let me draw a very mini conclusion before I hear Jordan's thoughts. Basically, what you're suggesting over here, so guys, here's an important thing. Basically, what your colleague is suggesting is we need to have a way to encode the kind of students' objects manually. Manually over here is really important. Manually simply means either use an integer, you got to define what 1 means, what 2 means. If you use several Boolean variables, also you got to have a way to encode it, right? Jordan, what do you want to say?
We have to check which kind of student it is with a lot of if statements.
A lot of if statement. That's exactly.
Just dynamic binding taking care of it for you.
That's exactly right. Okay. So now let me repeat what you said in just a moment. Okay. So now, can anybody link the following? Okay. Well, Jordan, actually, I'll mention what you just said. Let's say this. We have our student class over here. Let's say we simply got the kind attributes over here. And then let's say it's integer. We may have invariants over here to say maybe the kind should be between 1 and also 10, for example, right? Let's say 10 different kinds. And now, any potential supplier of the student class, any potential clients, they have to say, let's say, a test. And then let's say we have local over here. And then let's say test 1 and also test 2. You know what? Let me make it even better. Let's say we want to say charge and then students. Okay? Versus get tuition. And then let's say students. And this one is going to return, let's say, some tuition over here. Okay, just make it integer. So now, in the implementation over here, Jordan, tell us what should we do? For the first one, let's say.
For get tuition?
Get tuition, yeah, you can start with that.
So that student you would call SK tuition.
Get tuition, let's say we don't have that.
And you return the
Somehow you want, we want to somehow discriminate, right? To say if s.kind is something, I do something, right?
if it's student number 1 or 2 or 3.
Yeah. S.kind, yeah. S.kind is, for example, 1 or constant, doesn't matter. And then you do something. Else if s.kind equals 2, and then you do something. All the way to, you got 10 different kinds. You got 10 if-else if branches to write. I tell you what, if you only have to write this once, it may not be too bad. But what happened to charge? You got to repeat? You have to, right? Okay? I'm not going to repeat. I'm just going to copy and paste. All right, that's exactly what you're going to do, right? You're going to copy and paste and change something. Basically, the problem is, every time you want to really handle the students over here for this particular kind of design, you have to exhaustively check the kinds of student. You're repeating the if statements every time. Let me say one more thing. That's number one. Number two, what if we're adding a new kind of students? I'll put the question over here. What if adding a 11th kind students? According to the current setup, how many places do we have to change? 3? 2 or 3? Well, how do you figure 3? Oh, invariant. Yeah, I agree. Let's say it's already changed. So now, how many more? 2. Which 2? Yeah, how do you change it? You basically want to say, go to here and say, else if s.kind equals 11, do something. And do something very similar over here and say, else if s.kind equals 11, and do something. Right? You basically keep repeating the same pattern, even though it's not exactly the same code, but more or less it's the same nature. You're repeating it over and over. So this may not be a good design. Okay. Oh, I guess he doesn't care anymore. Okay, anyway. Yeah. It's fine. Okay. Guys, are we okay? I'm not spending this time for fun, right? This might be somewhere, right? That's fine. If you're comfortable with it, that's absolutely fine. Any question about here? Okay, yes, question.
Beyond just being the length of writing all those changes, doesn't it also make the computation longer? Because the compiler would have to go over.
Okay, you're talking about mainly about performance. Yeah. Actually, it turns out, this is some insight I'll mention again. I'll mention this first. Okay, it turns out either you use inheritance for this or without inheritance. Computation-wise, it will be the same. Because if you try to declare, think about this. I want you to imagine this. I'll put it aside over here. This is the solution without inheritance, right? Let's think about, you may have the following scenario. I have the student class over here, under which I have resident students. I also have non-resident students, let's say, okay? So now I don't have to have the explicit Boolean attributes or integer attributes. I don't need to. So what I do is I can simply say S is now declared to be a student. Okay? Somehow in my code, I can simply say s.charge. Okay? According to dynamic binding, which we're going to review for sure, maybe next week. According to dynamic binding, when we say s.charge, what's going to be happening at the runtime? Anybody? What's going to happen? Yep, somehow the runtime execution machine has to check what's the current type for S. If it is resident students, I'm going to call the corresponding charge version for the resident students. Otherwise, call another corresponding version. So this kind of if then else check will still be done, but not by you, but by the runtime execution engine. Okay? So the initial design you propose is basically doing what OO would do for you. Okay? Yes?
Would it make it better if we put that code into another feature or method?
Which code? You mean the if then else? Actually, the main thing, you definitely can put it somewhere else and make it a little bit better, but still you cannot get away from, you still have to write the if then else yourself manually each time. The fact that you're trying to work out the exhaustive list yourself for the if then else check is a bad thing. Because that could have been resolved if you simply got an inheritance hierarchy and let dynamic binding handle that for you. Yeah. All right. Guys, I would say this discussion is more valuable than the code reuse. Okay, I meant it. Okay. Yes. Yeah. Single choice principle. Yes, good question. Let me just discuss that before we end it. So now, let's say without the inheritance. So let's say we got the if then else check and also if then else check over here, right? Okay. Does that violate single choice principle? First of all, the principle is it violates single choice principle if you got duplicates. Do we have duplicates over here? We do. The duplicates are simply, for example, you can see we are checking this, we are checking that. That's one duplicate, right? And also, we are checking this, we are checking that. Second duplicates. So now, if I need to make a change, let's say, for example, let's say I don't want to have the second kind of students anymore, let's say. I only got 1, 3, 4, 5, 6, 7, 8, 9, 10, let's say, only that. In that case, what should I remove? I should remove every occurrence of that particular branch. So what I should do then would be I want to remove this. That's change number 1. And then I want to remove this. That's change number 2. So multiple places. In that case, you violate single choice principle.
So what if we have a set that only check the plane?
Yeah, no, actually, basically for every feature that needs this particular check, you have to write it out manually, explicitly. Yeah. Okay. All right. That violates the single choice principle. Okay, this is really important. Okay. Any questions until now? You okay? Questions? Yes. Is there any instance where you got duplicates but it does not violate single choice principle? I would say maybe not. Every time you got duplicates, that means you could have simplified your design further. You could have. Yeah, I would say. Of course, realistically, you may not actually simplify every occasion. I would say try to do as much as you can, right?
So this, you call it a name for this pattern that this example is for. If you said we're going to cover it later, what's the name?
The state pattern. State design pattern will be covered hopefully right after reading week. That's something we'll do. But we want to make sure you're comfortable with the basics for polymorphism, dynamic binding, right? Before the reading week, we'll make sure we review that.
So if you didn't have to do the check for get tuition, if you only have to change it for chart, would that not violate single choice principle? Because you only have to change. You only have to change.
Can you repeat your question again? Just so yeah.
So you know how we have that kind integer?
Yes.
We check it every time.
Yes.
When we change it, we have to change get tuition and chart. So there's
Correct.
2 places that we change.
Yes, correct.
But if we only have to change it in chart, would that violate?
I would say basically for your design, the reason that we say this particular design is not suitable is simply because there are certain scenarios when you change one thing, you got to modify multiple places. As long as you got that kind of scenario, it's a bad design. You shouldn't say, oh, simply because this scenario is going to work. But what about other scenarios, right? Yes. Yeah, I would say realistically, of course, we'll talk about ideal. Ideally, you should really try to avoid any duplicates in your code or your design. But I would say realistically, maybe you just have to do it. I would say try to do as much as possible. For example, let's say in your projects, when you document your report, I will just try to ask you, okay, show me one scenario in your projects where you satisfy the single choice principle. Why and why not, right? Yeah. Well, in the exam, maybe I'll give you certain design. I want you to criticize on the design. Maybe the answer will simply be, oh, because I can identify duplicates over here, and then so that I'm violating single choice principle. Yeah. Yes. I would say inheritance is one way to go. Yes, inheritance, yeah. Global variable is also fine. I would say, oh, you know what? Another way to get rid of a duplicate is helper methods. So what you're suggesting is, even if we make kind a global variable, it wouldn't help because you still have to do the if then else check. You still have to, yeah. Okay. We'll actually review this. Remember this kind of structure I'm explaining over here. We'll see that again for the state design pattern. Okay, we'll review this again. Okay, good.
So, with reference to what you said, what if you modulate your checking by putting in, when you use the helper method, by putting it through alpha? Is that still considered?
Nope. it is not possible to have a helper feature for this. It's not possible, simply because, notice one thing. What's being duplicated is, let me say that. What's being duplicated is the condition over here, the condition over here, right? So these condition checks are being duplicated. However, what's not being duplicated is as follows. What's inside the body of the if statements? That one should be specific to this particular feature, right? And also inside over here, that's also not duplicating, right? You know what? Since we already spent so much time, why don't I just do one more visual for you? I'm thinking on my feet. Hopefully that will work. If it doesn't work, you just forget about it, right? Okay. This is how you can think of it, okay? Without the inheritance, let's say this is what we have, okay? Let's say you have student class. And then we have the kind over here, let's say integer, okay? And then let me put in the same class, that'll be okay, I think, okay? Okay, and then over here, let me make it bigger, okay? I think it's worth doing, okay? Let me make it bigger. I want to really draw the visual connection between the without and with. Let's say this is our student class, okay? And then we have kind of type integer. And let's say we got charge and also charge something over here. And then for the do, we'll say if kind equals 1, then let me say we're going to do something orange over here, conceptually, all right? Else if kind is equal to 1, and then we do something that's green. That's a red, okay? And then end. Oops. Okay, that's one feature over here. Let me do just one more, okay? And then we'll be ready to do the illustration. So now let me do one more feature over here. Let's call that tuition. And you will agree, we have to repeat this check over here. I would say if the kind is equal to 1, and then I will do something, let's say that's pink. Over here. And then I just need a little bit more space. And then I would say else if kind is equal to 2. Sorry, that should be 2 here, sorry. And then now I'm going to do something, what about green? Green here, okay, we've got 4 different colors. Okay, and okay, let's make sure we are clear what this side is doing. Without the inheritance, we simply got a attribute over here called kind, right? So for the charge and tuition, we're going to do the same checks over there. If kind is equal to 1, do something. If kind is equal to 2, do something. Simply because charge and tuition, they are different. So the body for each branch should be different. That's why they're different colors. So now, how can we think about moving this particular design into with inheritance? Here's the bottom line. All the computation that need to be done cannot be avoided. They will still be there. You just decompose into different classes. How do we see that? Okay, let's see. First of all, we're going to have a class called students. Okay, let's make it deferred. Under students over here, we have a subclass over here called, let's say kind 1 simply means resident students. Kind number 2 means non-resident students, let's say, okay? So we have resident students versus we have non-resident students. Let's say at the student level, charge is deferred. And also tuition is deferred. Okay, so far so good? So now, how do we actually implement charge and tuition? How much code do we have to move over to these two classes? Should we move the if checks to there? We don't, because the inheritance hierarchy already makes sure dynamic binding at the runtime is going to take care of that. All we're going to move are the color part. Let's do it. Okay? So now, if I try this, so first of all, if I try the charge over here, what color should I put over here? Orange, right? Okay, let's make sure the color is not right, otherwise there's no point. Color, orange here, right? What about the next one? Let's say charge over here. So that should be this color here, right? This guy here. Right, you can see we completely got rid of the if then else check because it will be simply done when dynamic binding is in place in the runtime. Okay, let's do one more. So now we also got tuition. Okay, do and end, and also tuition, do and end. Okay, so now you can see for what happened to the tuition for resident students. Pink over here, right? Just put that here. And then also for the other one, it will just be green. One more thing to say. How does the inheritance work at the runtime? So now if I say S is of type students, okay? If I say creates, we'll talk about the syntax a little bit later, but I'm saying now I want to make a resident students. S dot make. If I say S dot charge, which color am I going to call? Orange or pink or green or red? Orange, because at this point over here, dynamic type is simply resident students. So we call it in charge, so go for the orange. Okay? Guys, it makes sense, right? Unless you're color blind. You're not, right? Okay. I want to make sure. Sorry, that's not relevant. I'm just asking. I want to check. All right. Anyway, I think I will spend quite a bit of time discussing this. I think this is important because you want to know, I tell you what, on the left-hand side, without inheritance, that will be more or less what you have to do in a non-OO language like a C. On the right-hand side is pretty much how you would do it in OO. If you're trying to do the left-hand side in Java or in IFO, you're wasting the OO power. Okay, guys, please. No, I'm saying for languages that do not have the OO feature, they cannot do the right-hand side. The right-hand side is only supported by inheritance.
So then if they want to do a pattern where like they want to add a new student, they have to use this.
They're going to use the left-hand side, more or less.
They have to.
Yeah? Yeah, before I take Shadi's question, okay. Oh, guys, please. Okay. So Tammy asked a very good question. What if you want to solve the same problem in C? Right? First of all, is there any class in C? No, you only got function, right? Also record. So now to really create a record, you have to include identifier for the objects, basically, to say whether that's a resident student or non-resident student. That's the only way you can do it. Okay? However, if you got OO, like a Java or C#, they will handle this kind of stuff for you. Okay? So nobody told you about this insight before, right? Okay, now you know it. Okay? I hope that you learned something. Okay? Okay, let me take one question. Okay?
I'm still not sure how does the inheritance like know which value or which color.
Oh, okay, good. The question was, when I actually call this guy over here, when I call s.charge over here, you're basically asking at the runtime, how do they know which objects I'm calling? Which should that be resident students or non-resident students? You can think about it, simply follow the pointer of S. S is currently pointing to the resident student, so they would know.
I understand that.
Mm-hmm.
It's not like you define it as what it is, but I'm saying like
Identifier? Yeah, you can think about, yeah, I tell you what, under the hood, this kind of if then else statement check has to be done, just not by you as a programmer. It will be done by the runtime execution machine. Okay? If you find yourself having to write the left-hand side to do all the if then else check, number one, you're wasting the OO features that's available to you. And number two, you're violating the single choice principle, right?
But like, so the values that are like the colors or something.
Yeah.
They are, let's say, numbers or pieces.
Yeah.
So do you define that if this class calls it, then give them this value?
No, you're going too far. Basically, when we review everything together next week, you will see that when you actually call this particular feature called charge, okay, for you as a programmer, you just have to know which object you might be pointing to, okay? That's the dynamic binding part that we'll review next week. Okay, I think I'll stop here, and then I'll see you next week.